So some more examples on OR probabilities. I'm going to just run through example 4 really quickly and I'll stop before example 5. Go ahead and pause when we get to example 5. Try that one for yourself. So here we're trying to find the probability of rolling a 3 or a 4. And what I keep saying is this is the probability of rolling a 3 plus the probability of rolling a 4 minus the probability of rolling a 3 and a 4 at the same time. So right off the bat, that one is not even possible. The probability of rolling a 3 is 1 out of 6. The probability of rolling a 4 is 1 out of 6. Yeah, we're still going to add those together. And we will get 2 out of 6, which reduces to 1/3. So the next example here, an odd number or a number greater than 2. So we're trying to find the probability of odd plus the probability of numbers that are greater than 2 and subtract the probability of being odd and greater than 2. So let's see, odd numbers when you're rolling a die, 1, 3, and 5. So there are 3 possible outcomes out of 6. Numbers that are greater than 2 would be 3, 4, 5, and 6. That's 4 out of 6. And then we have to ask ourselves, can a number be odd and greater than 2? And here, yes, it is entirely possible that that can happen. So we have to subtract. How many outcomes are odd numbers that are bigger than 2? Well, the only odd numbers we know of are 1, 3, and 5 when we roll a single die. So 3 and 5 are greater than 2. That means we have 2 numbers that fit that description. So we can just add 3 plus 4 is 7 minus 2 is 5 over 6. Go ahead and try number 5 for yourself. Hopefully you got these answers over here. A very brief explanation. The probability of drawing a jack from a deck of cards is 4 out of 52. The probability of drawing a diamond, 13 out of 52. Is it possible to get a jack and the diamond at the same time? Yeah, you draw the jack of diamonds. So there's only one card that fits both descriptions at the same time, so 1 out of 52 we subtract. So 4 plus 13 is 17 minus 1 is 16 over 52, and that reduces. The second example, drawing a club or a red card. So a club leads you to 13 out of 52. There are 26 red cards out of 52, and this one isn't even possible. A club is a black suit. It's in the black suit, so it can never be red. A red card can never be a club. So nope, that can't happen. So we just add 13 and 26 to get 39 out of 52, which reduces. Let's take a look at least once type of probabilities. So one thing that you can look here is that the probability event E, so we're just calling it E, happens at least once is 1 minus the probability the event E does not happen at all. This will require the use of AND probabilities. So finding the probability of having at least one boy when you have 3 children, at least one boy. So let's write that out. We have the probability of at least one boy is equal to 1 minus the probability of no boys, which would mean the probability of a girl times and a girl and a girl. And since we have ands in here, we can multiply all of these probabilities together. So let's just concentrate on this bit for right now. The probability of having a girl is 1/2 times the probability of having a girl is 1/2. Okay, 1/2, all right. We can multiply all of the numerators together to get 1. We can multiply all of the denominators together to get 8. So the probability that you get no boys out of 3 children is 1/8. So 1 minus 1/8 is the same as 8/8 minus 1/8, which is 7/8. You have a 7/8 probability, or something like an 87.5% chance that you will have at least one boy. All right, next example, when you roll a die 4 times, what is the probability of rolling at least 1 6? So probability at least 1 6 equals 1 minus the probability of no 6s, which means 1 minus the probability of not 6 and not 6 and not 6 and not 6. Notice I'm doing this 4 times. 1, 2, 3, 4, because we rolled the die 4 times. That's a pretty inefficient way to write things. Let's see if we can do a better way here. So the probability of not 6 would be something like this. What is just the probability of not 6? It would be 5 outcomes that aren't 6 out of 6 possible outcomes. And we've got this 1, 2, 3, 4 times. So we're going to multiply the same number, 4 of them, together. I think we can do this a little bit easier. Let's say this is 1 minus 5/6 to represent not rolling a 6. And since we're multiplying 4 of them together, why don't we just raise it to the 4th power? All right, yep, 4 times. Yeah, that works. All right, so let's figure this out. This is 1 minus 625 out of 1,296, and by this point we will use decimals to approximate. There is a 0.52 probability, or about a 52% chance, that if you roll a die 4 times, you'll get at least 1 6. So here are a bunch more of examples. What's the probability of rolling 2 1s, aka snake eyes, when you roll 2 dice? We've talked about that a little bit earlier. There's only one way, one outcome where you're rolling each die as a 1 out of 36 possible outcomes. I think that was in a previous lesson entirely. If Stan and Jennifer have 4 children, what's the probability they will have 4 girls? So that would be girl and girl and girl and girl. Oh my goodness, 4 times, right? So the probability of having a girl is 1/2. If they do it 4 times, that will be 1 out of 16. Each number gets the exponent. 1 to the 4th power is 1, 2 to the 4th power is 16. A bag of candy contains 5 Snickers, 7 Twix, and if 3 bars are chosen randomly, what is the probability of choosing all Snickers bars? Ooh, now it's getting good. So, look, I don't know if y'all out there are like me, But if I reach my hand into a bag and I pull out a Snickers bar, there ain't no way I'm putting that sucker back. So I feel like this is going to be without replacement. Be greedy with your candy. Don't put it back. So how many total outcomes do we have? Well, we have 5 Snickers and 7 Twix. So if I reach my hand into that bag the first time I feel a Snickers, I'm pulling that sucker out. I had 5 out of 12 chance of picking a Snicker. Okay, so I set that off to the side. That means now I have 11 candy bars left, only 4 of which are Snickers. So the chance I pull the Snickers out the second time is 4 over 11. Times, I'm reaching my hand back in there a third time, I'm greedy. If I reach my hand back in there a third time, there are only 10 candy bars left and only 3 Snickers left. And then I'm going to run away with 3 Snickers bars. But the chance that that actually happens, if we multiply everything across the top, what do we get? 60. If we multiply everything across the bottom, we get 1,210. We can reduce, I lied to you, this is 1,320. There we go. We can reduce a 0, leaving us with 6 over 132, and we can divide each of these numbers, top and bottom, by 6 to get 1 over 22. So that's a little less than 5% chance I'm pulling out 3 Snickers bars, but if I'm going to be honest with everybody out there, I don't care which ones I get. I'm going to grab 3, and I'm going to be a happy guy. All right, number 9. Each year, the probability of a major storm hitting Houston is 1 over 15, and that is right near, for anybody who's interested, about 6.6%. So it sounds like a small chance, and let's see what happens. It looks like we will, for each of the following, we'll run to write our answer in decimal form to the nearest thousandth. Okay, so let me double check here. If we're going out to thousandths, then I want to write this as 6.666%. Okay, or as a decimal, 0.066. There we go. That's what I was thinking of over here. Only 2 6s. All right. So find the probability that a major storm hits Houston 2 years in a row. That means we will have the probability of storm and storm. So that means the probability of a storm is 1 out of 15 times the probability of a storm is 1 out of 15, which is 1 over 225, which is something like 0.004 probability. So our chance of hitting a storm for 1 year is already pretty low. But our chance of hitting a storm 2 times, a major storm, 2 times in a year, to put this in terms of percent, 0.4%. It's less than 0.5% that it'll happen. That doesn't mean it can't happen. That doesn't mean it hasn't happened. It's just the chance that it will happen in the future is really small. All right, next, find the probability that no major storm hits Houston for 4 years. So I see this. So we're going to say no storm and no storm and no storm and no storm. That's too much work. I don't want to write all that out. What we can do instead is we can find the probability of no storm, which will be 14 out of 15, right? The other 14 chances, right? There are 15 outcomes. One will give us a storm, the other 14 won't. And I will just raise this to the 4th power. And with that, I'm going to just jump right to the percent and the decimal, because trying to write down those numbers are a little bit awkward. This is 0.759. And then again, to make sure people understand and make this understandable, that's 75.9%, which is pretty good. We've got better than a 3/4 probability that we won't have a major storm for 4 years in a row. I'll take that any day. What is the chance that at least one major storm hits Houston during a 4-year period? Well, we already did most of the legwork here. Remember, at least means at least one storm we can find by calculating 1 minus the probability of no storm, which we just did right there. Well, let's use this one. So 1 minus 759 is 0.241, or 24.1%. So over a 4-year period, there will be a 24.1% chance that we get a storm, which is still pretty low. I still feel pretty safe about that. These last 3 examples here, I'm just going to throw up some answers and talk my way through them. So very quickly, these last 3. When you purchase a lottery ticket in one state, the probability of winning $2 is 1 in 10. What is the probability of having at least one $2 winning ticket when you buy 5 tickets? So first we start out with this equation here. At least one winner equals 1 minus the probability of no winners. And the probability of not winning here is 9 outcomes out of 10, just as the probability of winning is 1 outcome out of 10 total outcomes. So if you add these together, the 1 outcome where it is a winner and the 9 where it is not would give you the 10 total outcomes. So we say 1 minus the probability of no winners, but since we're buying 5 tickets, that'll be an exponent of 5. And when you calculate or crunch this out, you get 0.40951, which rounds to 0.410. These last 2 are kind of similar. I had to make some wording changes because it just didn't make any sense. If you're only choosing one card, it doesn't matter if you're doing it with or without replacement, you're just drawing one card. So what's the probability of choosing an ace or, being the operative word, a face card when you draw one card from a deck of cards? Well, face card is king or queen or jack or an ace. There are 4 of those each in a deck, so 4 out of 52 plus 4 out of 52 plus so on. Add all the 4s together to get 16. Reduce this fraction to get 4 out of 13. The last one, what's the probability of drawing a diamond or an ace when you draw one card from a deck of cards? The wording on this was very, very ambiguous and would require some math that is taught outside of this course. So, what's the probability of drawing a diamond or an ace when you draw one card from a deck of cards? So ace or diamond translates to ace plus the probability of diamond minus the probability of any overlap. And there is one card that overlaps. It is the ace of diamonds. So we've got 4 aces in the deck. We've got 13 diamonds in the deck. We take one of them away because the ace is counted here, the ace of diamonds, and the ace of diamonds is counted here. So we take it away. 4 plus 13 is 17, minus 1 is 16 over 52, just like up here, and it reduces to the same answer. This concludes the lesson for 7B in contemporary math. Good luck.